live again to continue our online class, Computer Science 101. So, need to resume our last course. Okay. The week 1 we have finished already, so go next. We're going to go at week 2. Next, I finish it. So this is the week 2. I watched the video, but I will let you see it. I will let you watch it also, guys. Okay. So this is image for look.
So the top of this section is what's called a for loop. So if you look at the original flowers image, it's 400 degrees per second pixels wide, 300 pixels high. So if you multiply it to get rid of the total number of pixels, that's 164,000 pretty small matrix. So the way we were writing code before, where you have a line of control dots that way, but that's not a practical way. Operation on that is the small. So what we want is a construct where we can write a few lines of code to capture some changes, and then let the computer take the bookkeeping of running those lines of code again and again once it reaches its end. So the for loop section can use that. And this can be a big increase. Talk about the structure of this thing. I'm just going to identify the parts. So here in the blue box here, I have a picture of a for loop, and I'll just talk about what the parts are. So it starts off, I'll use my pen, with, this begins the for loop, so it has the word for, and then in parentheses it says pixel colon image, and there's a left curly brace to start to set off the next line. And so what this means is, and all this syntax is required, the parentheses, usually in my examples or in the exercises, it's the same every time. So usually we'll provide it and then just ask you to write the code on the following line. So what this means is, for every pixel in this image, please do the following. And then the following is defined as whatever is within the curly braces here. So these lines, side of the thing, that's called the body of the for loop. And this is just a few lines of code that can do whatever we want. So the way the for loop works is, and let's say we're working on the flowers image here, is it, here we have 3 lines, so it's going to take, let's say, pixel number 1 of the whole image, the upper left pixel. And so it isolates pixel number 1, and then the for loop runs these first 3 lines. So it says pixel.setRed 0, pixel.setGreen 0, pixel.setBlue 0. So those are all happening to pixel number 1, and really what that does is it changes it to black, right? It sets red, green, blue all to 0. So when the for loop gets to the bottom, funny thing happens. I sort of have this black arrow. It loops back up to the top of the 3 lines, and now it's going to isolate pixel number 2, the second pixel, and then it runs these 3 lines again. So it does them to pixel 2, and then it loops back to the top, and it runs the 3 lines again for pixel number 3, and so on. It just runs the lines again and again and again, once for each pixel in the image. So the other thing I should point out here is notice that the 3 lines in the body are indented. And that's not required, but it's a common convention to show that the lines in the body are kind of different from the other lines, right? Where this image equals new simple, that just happens once, and the print image, that just happens once. But the lines inside the loop are sort of special in that they have this quality that they're going to be run again and again. So let's try, we just run that exact example. So here I have it in runnable code. So this loads the image. Then I've got the for loop setting up the body. Here's the 3 lines of the body. And then it's kind of small here, but then there's a right curly brace, sort of balancing the left curly brace up here that closes off the body. So let's just run it and see what we get. So you can see what we get is just this pure black rectangle. And it's not very useful, but it does show what the for loop does. So what's happened is we had this original flowers image with all sorts of red and green and yellow and whatever in it. And what this code has done is it has visited every pixel on that image and done these 3 lines. And what these do is they set the red, green, and blue all to 0. So in fact, it just changes the pixel to be a pure black pixel. And so then, if you imagine that just happening over the entire flowers image, obliterating all the data, this is what we're left with, just this pure black color. So try a interesting example. So here, I'm going to say for each pixel, set red and green to 255 and blue to 0. So I want to think about, well, what's the code to do that? Very often for these problems, we'll have the pattern that in English, I'll say, well, do this effect set red to 255 or whatever, and then ultimately in the exercise, it'll be your job to sort of translate that into code. So here's an example of that pattern. So the code to put in the body to change red and blue to 255 and blue to 0 is just to say, the first 2 lines say pixel.setRed 255 and pixel.setGreen 255. And then the 3rd line is pixel.setBlue 0. So if I run that, what we see is just this bright yellow rectangle. So this is kind of similar to the previous example. We've just gone through and changed red, green, and blue for every pixel on this thing. In this case, the surface with a yellow color. So so those 2 examples, a little unrealistic, right? We just obliterated all the data and just made this colored rectangle. So now I'd like to try one that's a little more realistic, where we, instead of obliterating all the data in the flowers image, we work with it. So here's the original flowers image. And as we know, yellow equals red plus green. So we would expect that here, where I've got the yellow flowers, that the red and green are higher. So what I'd like to do for this example is set the red to 0 for the whole image. Think about what that's going to do. So the first question is, all right, well, what's the code to do that? In this case, what you see is I just have the line pixel.setRed 0 as the body. Now, in my previous examples, the body was like 3 lines of code. It can be anything, so it can be 3 lines or 6 lines. In this case, it's just going to be 1 line. And what this said, the sort of English translation of this for loop is for each pixel in the image, set the red to 0. So let's see what that looks like. What you see is there's sort of the flowers have changed to look like these kind of weird radioactive green flowers. And that makes sense if you sort of unpack, like, well, what made the flowers yellow before? Well, they were yellow because there was a combination of red and green light. What this code does is it just zeroes out all the red light. It's like we just turn that lamp down to 0 everywhere. And so what we're left with is just the green light that was making the images. The other thing to notice is look over here at the green leaves on the lower right. They don't look much different at all. So probably this was mostly green light to start with. The red light was maybe a value like 20 or something. And so when we change that to 0, well, that doesn't really make much difference. And one more example here. So for this one, I'm going to start with the flowers image, and I'm going to say set green and blue to 0, and red unchanged. So what is the code for that? Well, I'm going to have a 2-line body here. I'm just going to say pixel.setGreen 0 and pixel.setBlue 0. And I don't change the red, so it'll be like whatever it is. So we can run that. And what you see is now we get these red flowers. And what's happened here is this is actually called the red channel of the image. And what's happened is normally the image is this combination of red, green, and blue light. What we've done is we've changed both the green and the blue to 0. So we've turned those down to just be nothing. And what we're left with is sort of a map of where was the red light in this image. Where was red bright and where was red dark. And what we see is, well, over here on the left where it was dark, there was not a lot of red light. And also here, the green leaves, not much red there. And so really it's just the yellow flowers was this prominent area of red light. So that's just a way of looking at it. There's actually an analogous blue channel and green channel we could make to sort of look at those types of things. So the for loop, as I said, it turns out to be a very powerful feature that allows us to write a few lines of code and let the computer run them over just some sort of big data set, in this case, doing images. I should mention for completeness, JavaScript language you're using actually doesn't have a for loop that's as compact as this. It's just an omission in the language. So I added it just for this class to make it work here. So if you're doing some other JavaScript model, you won't have this. But many languages do have a for loop that works just like this. It's just sort of a weird omission in JavaScript. So the pattern here is that we get to write code, just in a sense, a short bit of code capturing what we want. And I would say that this reflects the theme of the idea that computers are powerful yet kind of stupid. So you write the code that's kind of interesting, like, well, I want to change the name in this way or that way or whatever. And then by putting it in the for loop, we have this partnership with the computer where the computer will take care of the powerful thing, like we're running that hundreds of thousands or millions of times. The computer handles that end, but it is also, the computer is really just doing something very mechanical there. And so I think that does show the general theme of how computers are. That there's sort of, the computer handles the mechanical part very quickly, but the person has to add the creativity to control what's actually going to happen. So in the next section, there's some exercises looking kind of like this, and then in the next section, I need to add just one more feature that will allow us to start doing image processing examples like this that are a lot more interesting.
Okay, need to be next. Oh, we should do the example he made. Okay, where this example? This example 1. Body 3 lines. Set red, green, and blue to 0. So he typed it already here. So we just need to run it. And there is it, the block. And the next example is for its pixel, set red and green to 255, blue to 0. The body code to do this. What the result? So it's here already also, and it's run it. So the yellow. So example 3. Previous examples overwrote all the flower data, not realistic. So work with the data in the flower page. Yellow flowers, red and green high, loose values high. The this pixel set red to 0. What is the body code to do this? So okay. Just set the red to 0, so it's already there. So let's run the, so there is it. Yellow and green only. And example 4 is set green and blue to 0. So which one? That's it. So next, what's the next? Let's agree with the assignment, and we don't have money to pay $199. So let's next. Week 2, image expression. So let's watch the video.
In this section, we're going to add what are called expressions to the code we have available. That's kind of the last piece we needed to start writing, kind of realistic image manipulation code. In particular, by the end of this section, we'll play with puzzles that are based on images, so that'll be kind of fun. So we've written code like this a lot of times. So here it says print 42. We just have a number, 40 or 100 or 250 or whatever, and it's just in the code. It turns out you can instead write that this way. So it says print 11 plus 31. And the 11 plus 31 here, that's called an expression. Basically, instead of a fixed number that's thrown ahead of time, we can put a little arithmetic expression. So in this case, 11 plus 31, it's a little problem. The way this works is that when the computer runs, when it gets to this line, the first thing it's going to do is it is said to evaluate the expression. So it just picks out the expression and says, all right, well, I need to work out what number this is. In this case, it just does the addition. So 11 plus 31 is 42. So once the expression has been evaluated down to a number of 42, then the code can continue and just use that number. So in effect, this will just print 42. And so anywhere in the code where we would have had a number like 0 or 255 or 100 or something, instead we're going to be able to put little arithmetic expressions to sort of embed a little computation to compute what number we want to use. And that's going to enable us to solve better problems. So we haven't talked about it up to now, but the pixel has these 3 extra functions. There's pixel.getRead, and what getRead does is it's kind of the reverse of setRead. It retrieves the number out of the pixel. So there is some red value, 0 or 100 or something. This retrieves it out. And there's also getGreen and getBlue. And so these are going to be very natural to use in expressions to mess with the RGB values in the pixel. So suppose what I want to do is double the red value of the pixel. So if it's 50, I want to make it 100. If it's 100, I want to make it 200 or whatever. So here's some code that does that. So I'm going to walk through this. And this is this idea of making a relative change to a pixel, whatever it was, change it to triplet or something like that. That's going to be a much more realistic way to deal with pixels. So let's walk through what this code does. So this code is correct. It does double the red value of the pixel. So what the first line does is it calls pixel.getRead, so that's going to retrieve the number out. And let's just say, in this case, that the red value is 50. So pixel.getRead is going to retrieve the 50. And then here we're using the equal sign, as the way we had before, to just store that number in a variable. I'm just going to call it old. So basically, this just stores 50 in old. So then the next line says pixel.setRead old times 2. So here I'm using an expression. And remember, the way it works is, when it gets to this line, the first thing it's going to want to do is evaluate the expression. So it's going to look at old times 2. Old, remember, it's just storing 50. So basically, this says 50 times 2. It's going to evaluate that and come up with 100. So it evaluates the expression to get 100. And now that it has that value, then it can go ahead and run the code. So it says pixel.setRead, essentially 100. So if you think through the whole sequence, basically this pulls the 50 out, multiplies by 2 to get 100, and then stores that back. So in effect, it multiplies by 2. Now, this is the way we're going to write it. The whole thing can be condensed down to just one line, because really that variable old there wasn't adding a lot. It was just kind of a temporary holding spot. And So let's imagine that same case of a pixel where the red value is 50, and I'm just going to run this. I've just condensed it down to one line. So let's imagine this code. So I have a pixel with, I have it, pixel with red of 50. I'm going to run this line. So the first thing it's going to do is it's going to notice that there's an expression here, pixel.getRed times 2. So it's going to evaluate that expression. So pixel.getRed is going to go get what the red value is currently. So let's say 50. So it'll say same as we had before. So 50 times 2, that's 100. And so then with that value 100, essentially it's going to call pixel.setRed of 100 to put that back. So it works out as the same dynamic feature. So it gets out the old value, multiplies by 2, puts it back. Or in effect, sort of in English, it doubles the old value. So I'll do a bunch of examples that follow sort of this pattern. So what we're going to see is I'll start using this inside of loops, is whereas previously we had to, say 0 or 2, we would have some fixed number. But now we're going to write code, and this is the example I just did, code like this, where we're going to change the red value based on what the red value was before. And so the dynamic is we'll have, very often we'll say pixel.setRed, and then in the parentheses we'll call pixel.getRed, and then have some arithmetic. So in this case, this line doubles the red value, or ultimately, this line calls pixel.setRed and pixel.getRed times 0.5. So it's getting the old value and multiplying it times 0.5, or essentially dividing by 2. So it's going to make it smaller and then put that back. So that's going to be, we'll follow that pattern. All right, so we're going to get to a example here. So suppose I'm going to take the flowers image, and let's say I want to make it look kind of more orange. So my strategy is going to be, well, let's change the green value. Let's just turn down the green. And so mathematically, I'm going to say, let's change the green to be 75%, or whatever it was. Now, in this example, I've actually started the page with no code in it. So I'm just going to actually type this in. So I'll say pixel. So if I want to change the green to be 75% of what it was, this is similar to the example I just showed, I'll say pixel.setGreen. I'll sort of write this outside in. So I'll set green, and then I want to put some kind of expression here, right? So what compute a number that I want to put back in the green value. So the pattern I'm going to use here is I'll say pixel.get get the old value, and then I can kind of multiply times whatever. In this case, I'll multiply times 0.75. So I'll change it to be sort of 3/4 or whatever else. Let's try that. Okay. That does make it. If you recall, it was sort of yellow. Actually, if I put 1.0 here, which is make no change. Right, so that was when it was nice and yellow. So 5 back here, we got kind of a little more orange. I should say for these examples, I'm gonna just take the time to type the code in, and you could do that if you want to do that yourself. There's a little show solution button down here. So if you come to review later, the solution code is available, but I just felt like for practicing purposes, it's better to start with a blank screen and then really go through the process of typing code. So all these examples will follow. Let's try something a little more difficult. So this says set red, green, and blue each to be 0.75 of their original values. And then try 0.5 and 0.5. So what I'm going to do, a great computer science tradition, is that instead of typing the code in absolutely from scratch, I'm going to copy it, the one I made before. I'll make 3 copies of it, and then we'll fix it. Okay, so usually I always go in the order red, green, blue. So I'm going to say set red to get red, and what did it say? To 0.75. All right, so that's good. And then we'll say set green to get green, and then we'll do blue next. So set blue, pixel down, get blue. So you can sort of see the pattern here of set and get being fine. That's fine. This is a very workable pattern. So I'll run it that way. It's a little bit subtle, but what this has done is taken the original image and made it a little bit darker. So if you think about it, by multiplying 0.75, we're sort of moving everything towards 0. Obviously, 0, 0, 0 is pure black, so we're kind of pressing down that way. So let's try making it a little more extreme. So I'll multiply 0.5 on that. by 0.25, so just a quarter of the original values. Oh, no, it's getting kind of dark. So this shows a good, realistic, sort of interesting use of this kind of scaling idea of using setRed combined with getRed and multiplying times sort of number to sort of play with the values, either scaling them up or scaling them down. So there's a third problem here. I'm going to sort of skip over. This one's just for extra practice. If you want to come and try this one, and it has so what I really want to do is work on these 5, 10, 20 puzzles. So the idea with the 5, 10, 20 puzzles is that there was some image of a flower or something, and it's been modified. And the way it's been modified is that the red, green, and blue values have all been divided by either 5, 10, or 20. So the values are way too small. The image is going to be really dark. And the challenge is to multiply the red, green, blue values by either 5, 10, or 20, essentially to kind of undo the darkening to kind of get the image back. And so essentially this just comes down to sort of experimenting and playing around a little bit to try and figure out how to get the image back. The number 5 is used once, the number 10 is used once, the number 20 is used once. So basically you just have to figure out which one goes with which color. And I should say, there's only 6 possible ways to have 5, 10, and 20. So there's not really that many to go through. The way I think about it is you could imagine, well, maybe the 5 is first, is on red. And so then there's either, if 5 is first, then there's either 5, 10, 20, or 5, 20, 10. So if 5 is first, there's only 2 possibilities. And then likewise, if 10 is first, there's only 2 possibilities. And if 20 is first, there's only 2 possibilities. So that's the way you can kind of organize your assertion. All right, so let me go back here. Before I grab copy my code, so we don't start with nothing. All right, so in this case, what we have is a banana. Actually, here I'll comment these lines out for a second, so we can just see what the image looks like with nothing. So there is the puzzle image, and what it shows, I'll tell you, there's a yellow banana, and it's on a background of dark red bricks, and in between the red bricks, there's little bits of the moss. So if you fix the image, we should be able to see all of those things. So to fix the image, what I want to do here is multiply. I'll just start with 5, 10, 20 like this. So I'll say, well, let's guess that the red needs to be multiplied by 5, the green needs to be multiplied by 10, and the blue has to be multiplied by 10. It's just a guess. So if I do that, well, that's clearly wrong. Right? The banana doesn't look quite right, and the bricks have this sort of blue cast, so that's not good. So I'll stick with the assumption that the 5 is first, though, and I'll try the other permutation. All right, well, so maybe it's 5, 20, 10. Try it that way. Ooh, that's worse. All right. So I don't think the 5 is first. Right? I tried the 2 ways with 5 first. So let's try the 10 first. So I'll try 10, 5, 20. I'm just scaling these up. Well, I mean, I think we're getting there, right? I mean, the banana looks pretty good. But the bricks obviously are, that's purple. They're supposed to be red. So let me try, I'm going to try leaving the 5 in the middle. 20 first. 5, 10. Ah, there we have it. The banana is nice and yellow. See the bricks have this dark red color, and then even little bits of green moss here. I'm going to zoom in on this. I'll show you some qualities of it. So partly there's the brick and the moss. Yeah, that looks good. This is just a minor thing, but you'll see there's kind of sort of this horizontal banding in the banana, and that's okay. That's the way the solution looks when we do it correctly. That's happening because when the red and green and blue, when they were divided by these numbers, by 10 or maybe 20, all of those values, which normally range from 0 to 255, they were compressed down to ranging maybe just 0 to 12 or 0 to 12. And as a result, because they were compressed down to that range, there were just a few shades of yellow available when it was compressed down like that. And even when we expanded back up, we're still stuck with just those few few shades. So that's what we're seeing in these horizontal answers. There were just a few different shades of yellow, and so it's unable to capture. It's unable to capture the real gradations that you want. So that's just sort of an artifact of the way the section is. All right. So the exercises to follow this section are actually just more of these 5, 10, 20 puzzles. So you should check out.
Let's check out. So guys, let's check out. Here's the example. So this is the example 1. Suppose we want to change the yellow flower to look like orange. So set the green values to 75% of its original value. So let's do it. So pixel that set green pixel get green get green. Oops. 0.75. So let's run it. So there is it. Here's the image. To be the just suppose we want to change the yellow flowers to look like orange. So the yellow flowers now is orange. So there's the show image here if we are correct. Show code at orange. So this is set pixel, set green, pixel. So we are correct. So next example, set red, green, and blue to be 0.75 of their original values. Then try 0.5. Okay, let's do it. Pixel that set red pixel that get red times 0.75. Pixel that set green pixel that get green times 0.75. Pixel set blue pixel get blue times 0.75. So let's run it. Hmm. Let's see, this is it. Let's change it with the 0.5. Let's run. So that's it. It's become darker. What is the next number? 25. Let's add here. Yep, yep. Okay, run. So it's more darker. So let's show the code if we are right. So is it? It's correct. We did it. So example 3. Still trying for orange on the flower. Try to modify both red and green. Change red to be 1.3 times with its original value. Change green to be 0.25 with an original value. So that's all. We will do it. Red is 1.3 pixel. That's it. Red. Pixel. That get get red times 1.3. Next, pixel that set green pixel that get green times 0.75. Let's run the image. Oh, error. This one is error. Pixel get green. Okay, there's no N here. Okay, so use it. Orange. This is the puzzle. Let's show the code first. Where this were right. Next, banana. It's between the bricks. So this is what the professors saying pixel that set red pixel that get red times times 20 pixel. So let's get the final answer. The answer green pixel that get green times 5 huh? pixel that set blue pixel that get blue times 10. So let's run it. So I set the banana and the red bricks. So let's share the code. So that's the answer. Okay, let's go next. There is an assignment again, but I cannot do that because we don't have money to pay for that. It's next puzzle. Image puzzle. So let's watch this gold puzzle.
This is just a short section to introduce a type of puzzle, which is built on the sort of image manipulation code we've been doing. So the idea is there's a picture of some mystery object, and the red, green, and blue values in the image have just been messed up in some way. And so what you need to do is write code to fix the red, green, and blue values, and so reveal the original image and see what it is. So here is an example I'm going to do here. This is the so-called gold puzzle. And the idea, so there's some object is shown here. And what's happened with this is that, first of all, the green and blue values in the image have been just set with random values between 0 and 255. And actually, if you look at it, so it gives it kind of a snowy appearance. And you can kind of see there's some pixels where the green is very high, some pixels where the blue is very high, they're just blue or green. And then there's these sort of turquoise pixels scattered through. So those are cases where both the blue and the green are high. So that's one level of mess up in this image. The other thing that's happened is that the image that we want to recover, it's in the red values. In fact, it's exclusively in the red values. The green and blue are just sort of garbage. but the values have been divided by 10, so they're very dark. So kind of what we're seeing here in the obscure version is there's a dark red image behind there, and it's been covered with this sort of bright, random green blue snow, so we can't see it. So what we want to do is write code to fix it. So let's turn off here. So as usual, for these, I'm going to start off with just a blank text area to just write the code. And then down here, there's a show solution button. So if you want to visit this page and try yourself. All right, so the first thing I want to do, so here's what it looks like. If I just run it, right here, the loop is empty. So if I run it, we just get the draw. So the first thing I'm going to do is I'll say pixel.set green 0. I'm going to punch out the green values. I'm just going to get rid of them, and we'll see what we get. All right, so now, well, it's better. Now we just have this blue snow. We've at least gotten rid of the green snow. So I'll get rid of the blue snow as well. I'll say set blue 0. Let's try that. Nice. So I've got rid of the snow, but now the problem is that the image, which is in the red value, it's just so dark, you can't see it. So it's technically there, but it's invisible. So what I need to do is scale it back up. Right? It's down there, I just need to make it brighter. So I'll say pixel.set red, or pixel.get red. It looks a little bit like the 5, 10, 20 compass here. So I'm going to, in this case, it was, the instructions say that it was scaled down by a factor of 10. So I'll scale the red back up by a factor of 10. So that is the solution image. So this is a picture of the Golden Gate Bridge, as the San Francisco side. Now, it's a little, obviously it doesn't look quite right. What's happened is that because the data is exclusively in the red, even when we recover it, it just looks red. I mean, what's happened actually is this is essentially a black and white image, and normally those are shown on a sort of black to white spectrum. In this case, the image is being shown on a black to red spectrum. So it is the right image, but it has this red cast. For this section, we're going to say that's good enough. You can see what it's supposed to be. In a later section, I'll show how to fix that and get it to look like a proper black and white image.
Okay, so we will do that section. Set image non-puzzle object with gray and blue values been distorted, hiding the real image. Write code to fix the pixel. So it's write the code. The green values are just random values. The data real image because of the red values. The addition to red values has been divided by 10. Okay. The green and blue snow is obscuring the real image. Write the code to cover the image. Okay, let's do it. Pixel dot set red. Now set green. Set green to 0. Next, pixel dot set. Oh, green is missing the end. So set blue. Pixel dot set red red. Times to 10. Random image. There you go. That's the answer. So let's show the solution for there if we are right. Yes, it's right. So let's move on to the next section. It's another assignment and we don't have. We got just to go next. Grayscale image. So let's, what's the grayscale image? Okay.
In this section, I'm going to talk about how to make grayscale images and codes to play around with that. So the first question is, how do you make a gray color? So to play around with that, I'm going to go over here to the RGB Explorer. And it turns out in the RGB scheme, the way to make a gray color when it lacks in hue is for all three numbers, red, green, and blue, to be the same. So I can demonstrate that here. I'm going to put red and green to be small 190. So you can see that's kind of a red yellow, and blue is down here. So watch what happens as I drag blue up towards being the same as red and green. You can see the color is kind of drained out of it. And just as blue gets to be exactly the same, you can actually use the arrow keys. There. Now that all three are exactly 190, what we're left with is just gray. So we can do that. So if I put, I'll put green and blue, and there's sort of the middle. So we'll go for 99. It's a dark turquoise. I put red at 0. So then I'll bring red up to be closer and closer. And once it is the same, those two then gray. In this case, it's kind of dark gray. So the pattern is, if red, green, and blue values are all equal, they're all the same, then that's going to be some shade of gray. And actually, our original cases, pure black and pure white, they follow that too, right? And black is 0, 0, 0. They're all the same. So that's actually one endpoint of the grayscale spectrum. I'll go back here, and we'll say that so we can make these if we put all the RGB values to be equal, that'll make a shade of gray. We can make dark gray, light gray, whatever. We'll say that those shades of gray. Another way of saying it is that they lack like that. It's just this colorless brightness. So in this table, I just have some examples. So for example, if I had something that was 50, 50, 50, it's like a dark gray, or 120, 120, 120, that's medium gray, or 200, 200, 200, that'd be a light gray. And as I said before, the pure black and pure white cases that we talked about before, those sort of things. All right. So how can I do something useful with this? So I'm going to look at this unusual image here, the Liberty-Red. I'll just run this code. Right now there's no code. So the Liberty Red image here, it's a picture of the Statue of Liberty, but all of the data is in the red values of the pixels. So the red values are 37, 200, whatever. They're varying to show the same. The green and the blue values are just 0 everywhere. There's nothing there. So I mean, it looks bad. It certainly looks wrong. So I want to think about, well, how can I fix that? I'd like to fix this to look like a grayscale picture of Statue of Liberty, not this. So let me do this. Well, I'm going to use this, the fact that the green, blue, and red are all the same. That's going to be a shade of gray. Now in this case, the data is for each pixel is in the red value. So if I say pixel dot set green, what I'm going to do is I'm going to make the green value, I'm going to change it to be the same as the red value. do that by saying pixel dot get red. So what this does is with the pixel dot get red, that sort of picks the number out of, for at least for each pixel, it picks up the red value, so 27 or 100 or whatever it is, and then sets it in to be the green value. Now this is a little unusual. Usually what we call set green, we've mixed it with get green, and set blue we've mixed with get blue. But this is a valid combination as well. It happens in this case, it goes quite well. So then I'll do it again for blue.
Blue.
So pixel dot
Pixel get.
get red. I'll set that as blue. Let's try that. So this is just an application of this feature of the RGB space, the number of fullest grayscale. And so I sort of retrieved the value out of the red, and I set it over to the green. So now it sort of fixes the image. So it's black and white, but at least it looks okay. So a related question, a more practical question is, well, if I've got a color image, like so flowers image, how could I convert it to grayscale? And the way I'm going to think about that is, if we're looking here at these flowers, it's like, well, I want to drain the hue out of it. I just want to think of each one of these pixels as being dark or light, just having some amount of brightness. And obviously there's many examples of this image. So suppose, so the problem is going to be looking at a pixel, how dark or light is it? That's what I want to do. So suppose I picked 3 pixels out of that image, and I put them in this table. And I want to think about which one of these pixels is darkest and lightest. So here's the first pixel, and here's the second pixel. So I'm just trying to judge light versus dark. Who's the light? What's the lightest? What's the darkest? So suppose if I was just looking at the red values, I'd see that this first pixel has a red of 200. And then that's just much brighter than the others, right? I mean, high numbers are bright, 5 is the max, and 0 is black. So it looks like, oh yeah, this first pixel, 200, that's clearly the brightest. But then if I look over in at the green values, it's like, oh gosh, but this third pixel actually has a really high value for green, even though it's kind of low for red. So I'm not quite sure how that balances against the other pixels. So it's hard because essentially what we see is that you can't just look at one of red, green, blue to judge how bright the thing is. You sort of want to count them all. So our solution in this case, which I have in the full column, is to compute the average for each pixel. So each pixel has a red, green, and blue value. What I'm going to do is just compute the average of those 3 numbers. And the way to do that is you just add them up. So I'm just going to compute red plus green plus blue for each pixel, and then just divide by 3. So that'll give us the average value of the red, green, and blue. And that average value is going to work as a pretty nice summary of just how bright the pixel is. Right? So if the average is 0 or 10 or 20, some low number, we don't know what hue it is exactly, but we know it's dark. And at the other end, if the average is 220 or 240, again, we don't know what the hue is, but we know it's bright. So the average is going to work as a kind of a summary of the pixel, where it drops out the hue and just gives us one number, 0 to 255, that just captures the brightness. Now I should say, there's other ways of doing this, but just computing the average is simple and it's fun. There's no fun for averages. So in this case, I had these 3 pixels, and so here on the right-hand side, I just computed the average. And what we see is, really the third one is by far the brightest. If you look at all 3 of red, green, blue, and then the middle one is the darkest, and the first one is the all right. So I can use this idea that I've got the average, and it sort of makes this nice one-number summary. I can use this to convert something to gray. So let's try this. So here I've got the, let's run this. So inside the loop, there's no code here, so if I just run it now, we can see the image change. So what I'd like to do is add the code here to change this to grayscale. So I should say my strategy is good. So what I'm going to do is, in the loop, for each pixel, I'm going to compute this average number. So just get one number. So it might be 27 or 100 or whatever for each pixel. And then I'm going to take that number and set it into the red, green, and blue. So if the average is 27, I'm going to make red, green, and blue all be 27. And if the average is 211, then I'm going to make red, green, and blue all be 211. So that converts each pixel into the grayscale spectrum we're starting with. So first off, I have to use the average here. So I'm just, as I said, you add them up. I'll say pixel dot get red plus dot get green plus pixel dot get green. And I'm going to put those three inside of this outer set of parentheses, just for the order of operation. So I want to do the addition, and then I'll say slash 2. So this does the addition in the parentheses, and having gotten that sum, it divides by 3. And I'm just going to store that in a variable called ABD. And this line, it's going to turn out to be kind of a stop line for us. There's many little techniques and problems that we'll do in the future where we want to compute the average. All right, so what did I say? So my strategy is I compute the average, and then I set red, green, and blue to already use that. So I'm going to say pixel dot set red, and then here I've stored the average. This is just a variable, so I've stored the number in there, and then inside here, so I can just say ABG. I'll just go to that variable and get the number back out. And likewise, I can say set ABG. Okay, so let's try that. Okay. So you can see this is it works. So it's gone through all these pixels, red, green, or whatever. It's reduced it down to this one average brightness number, and then set that back. So we think this looks really good. So actually, I'm going to test it out on flowers. I'm going to go back to poppy image, which I'm cruising a little bit efficiently. If I comment these three lines out, and just run it right now, we'll just see the poppy image. See, it's obviously nice. Orange, poppy look, and then that kind of thing. So now I'll put these lines back. We'll try there we go. So you can see, obviously, the orange and the green, it's all been drained out, and each pixel has been reduced to just the brightness. Texture on the front of the poppy still. So there you have it. Suitable for framing. Right. So a question that often comes up with this code is that line, average equals, and then just one more for the average. Does that need to be inside the loop? It feels like perhaps it could be just here up after the image equal sign. And the answer is no. It can't be up there. It does need to be inside the loop. And the reason is, what you could think that this line sort of sets up a relationship about average that must be true for all time, like as if it's just true at all times as the program runs. And that is not how computer code works. Computer code is less sophisticated than that. What this line does with the equals is it just evaluates the right-hand side and assigns it into this variable on the left-hand side when this line is run. So if we were to put this up at the top, it would just run once, and it would store some number in ABG, and that would be it. In this case, remember, we're inside of this for loop here, like the body, and so this code is running thousands or maybe millions of times, once for each pixel. And those pixels each have different red, green, and blue values. Right? So this sum is different thousands of times. And so what we need is to compute this sum anew for each pixel. Each time we see a new pixel, we need to redo this math. And so the way the equal sign works is it's just evaluated when the computer runs a process. And so for that reason, because each one of these pixels is different, we need to put it, very often we'll just put it as the first line inside the flow. So that's why that. All right. So just to kind of summarize, so we've learned this quality that if red, green, blue are all equal, that's just correct. And we've got this technique fun. That's going to be, I'm using it here for grayscale, but actually in the future, so it's just a useful thing to know. And finally, I'll say that this line, I was highlighting before, average equals average equals divided by 3, that's going to be kind of a stock line. So we're going to end up using exactly that line later. In fact, it should show up in some exercises.
Exercises. Another exercises. So let's choose the image to grayscale 1. So let's make it grayscale. Ah, VG. VG equals pixel pixel dot set green red class pixel dot set green class pixel dot set blue. Divided by 3. Oh, so I forgot this. Show code. Yes, go to average. So we still need to close this one. So this cell set. Okay, get pala yun. get the average. So we're wrong here. That's it. Let's get Excel. That's it. Red average. GB. AVG. Excel. That's that. Then AVG. Excel. That set. AVG. So run it. Oh, get rid should be immediately followed by. Okay, there's no. That's what you mean. Okay. Fine. What? What is the wrong I did? Okay, okay, okay. There's no parenthesis. Cook, cook, cook. Okay, let's try this. Unexpected token, where is that? Saan ba yun? Ibang mali. Hmm. talking dyan. Okay, wala na palang ano ito dapat. Wala na. Ito. So, let's try na. Ay, go. Pala nga. Kuha din. Ahay. Syahada. Okay. Next. So, assignment again. At, look that one. Next. So, it's finished. This one is week 3. So, thank you guys for watching. Bye-bye.